We are busy with geometry of two-dimensional shapes, and we are focusing on exercise 13.7. We are going to have a look at number 5. For number 5, angle DBC, in other words, this angle here, is equal to angle ACB. In other words, this angle here, and they are both x, that is given. And then also BAC, this angle here, it's given as y, and then CDB, in other words, this angle here is also equal to y. So we have x and x, y and y. Those are the only ones that are given. So we have to prove now that triangle ABC, so this large one in red, ABC, is equal to, or congruent rather, to triangle DCB, which is this one mostly in blue, except for this line, which is the red one, but it is common. It's common with the red one. We could just as well have made it blue. So we know we have an introduction, a body, and an essay, or a conclusion rather, in our essay. So let's start with the introduction. So for number A, we have in triangle ABC and triangle DCB. So that's our introduction. Now we need our body, which consists of three portions or three main points. Now the first one we already alluded to. We have this common side, so we can say BC equals CB. The reason being it is common. Then secondly, we can look at what was actually given to us. We know this angle X and this angle X, they form part of the two triangles. The red one form part of the red triangle, the blue shaded part form part of the blue triangle. So we can say therefore that angle DBC is equal to angle ACB. That was given to us. And then lastly, for our body, we can look at y. It is part of the blue triangle, and then we have this y, which forms an angle of the red triangle. So we can also say angle BAC is equal to CDB. So it's angle D. So we have angle A equal to angle D, because remember, order is important. We have angle B equal to angle C. Yes, our order holds. So now we have a side and we have two angles. So in conclusion, we can therefore say, therefore triangle ABC is congruent to triangle DCB, and our reason will be angle, side. Now that we have proven triangle ABC congruent to triangle DCB, we next need to prove that triangle AEB is congruent to triangle DCB. Triangle DCB. No, DEC. So this triangle here we need to prove congruent to this triangle here. Now, a good practice is, once you have proven triangles as congruent, to fill in the additional details that you learn from that. So, for example, we know that angle A must be equal to angle D. So, in the red one, angle A to D, well, that was anyway given to us. Let's compare angle B and C. So angle B in the blue one is C to the red one, that was given to us. Now angle C equals B, or that was also given to us. Let's look at the sides. Side AB is DC. AB is equal to DC. Now that wasn't given to us, so let's go and fill in those details. So these two sides we now know are definitely equal. So BC equals CB, well, that we already used when we proved, that's common. And now AC equals DB. So AC is equal to DB. So that's some additional information we know due to proving triangle ABC congruent to triangle DCB. So now let's prove this triangle and this triangle congruent to each other. So once again, we start with our introduction in triangle AEB and triangle DEC. We have a body of 3 points where firstly I can see we can use already from the congruency aspect that these two signs are equal, the congruency of ABC and DCB. So we can say therefore that AB is equal to DC, and our reason for that is triangle ABC is congruent to triangle DCB. So secondly, we know that y and y equals the same. So therefore angle BAC cap at the wrong place. Let's just rewrite. BAC is equal to CDB, and that was given to us. And then thirdly, I can see we have this angle staring at the other angle where they cross, so we know it's vertical opposite angles, so therefore E3 equals E4. So it's angle E3 equals angle E4. That's from vertical opposite angles. So now we can have our conclusion. Therefore, we know that triangle AEB is in fact congruent to triangle DEC. Reason, so we have a side, we have two angles, so it's angle, side again. Now that we have proven that triangle AEB is congruent to DEC, let's just see what properties we have in addition due to proving that congruency. So we know angle A is equal to angle D. So angle A equal to D, that was anyway given to us originally. Angle E equals angle E, well, that we have already shown previously. So then angle B is angle C. So we have angle B is equal to angle C. Let's just indicate that which we also have shown previously anyway. These two are equal. So now that we know that, let's move on to number C, where we want to prove that triangle ABD is congruent to triangle DCA. Just before we do it, let's just get back to the side properties. We haven't investigated those properly for the previous proof. So AE is equal to DE. So we know that's also proven as true. So let's indicate those. And then EB equals EC. So we have EB equals EC. So that's another one that is true, so basically it's not only BD that's equal to AC, but also BE equal to CE. And then we also know that AB equals DC, so AB equals DC. Well, that we anyway knew from the first proof of congruency. Okay, so now that we have that, let's focus on C. So we have ABD, we need to prove congruent to DCA. So let's start with our introduction. So in triangle ABD and triangle DCA. For our body, we know that AD equals DA, AD equals DA because it's common. So AD equals DA. It's common sides. Secondly, we know that AB equals DC, that we knew from the first congruency proof. So AB equals DC, AB equals DC. That's due to triangle ABC being congruent, being proven as congruent to triangle DCB. And then thirdly, when it comes to the body, we know that AC equals to DB. So AC equals to DB, AC equal to DB, or you could also say BD, BD equals to CA, CA. So BD equals to CA. And that we also know from the first congruency. So it's because triangle ABC was proven congruent to triangle DCB. So now we are ready for our conclusion. So therefore we can safely say that triangle ABD is congruent to triangle DCA, and when it comes to reasoning, it is in fact three sides. So it's side, side, side. Now that we have proven that triangle ABD congruent to triangle DCA, let's see which additional properties we can indicate. So we have angle A equals angle D. So angle A equals angle D. So we have that whole angle here. Is equal to this whole angle here. Then we have angle B is equal to angle C. Well, that we already had. And then angle D equals angle A. Angle D equals A. Well, we already had that from here, A and D. So let's look in terms of sides. AB, DC. AB DC, we already had that. BDCA, so BDCA that we already had, and ADDA. ADDA, well, we use that as part of our proof. So, well, so only these angles additional that we know from that congruency. So now that we know that, number D, we need to name two isosceles triangles. So isosceles, we know it's where two sides of the triangle are equal length. So I see already here we have an isosceles triangle with these two legs equal. So we have triangle BCE. So we have triangle BCE, and then here we have 1, 2, 3, 1, 2, 3. So this leg and this leg is the same length for triangle ADE. Now from number D, we know we have the two isosceles triangles. Let's just use those properties to indicate what additionally we know due to them being isosceles. Since this side is equal to that side, the opposite angles will also be equal. So opposite to side DE, we have this angle A. I'm just going to use a little dot to indicate that, black dot, and so here we also have a black dot, and then we also know that these two angles are equal. That we already know due to opposite this side we have this angle, opposite to that side we have this angle. So we anyway knew that already long time ago, so this is just confirmation. So furthermore, we have these two angles staring at each other, so we know opposite vertical opposite angles are equal. I'm just now going to call them Z and Z. Okay, so they are equal, and we want to prove that A1 equals X. Now this fact that vertical opposite angles are equal is going to be crucial in proving that angle A1 is equal to X. So I'm first going to write that statement down, therefore. So we can say E1 equals E2, angle E1 equals angle E2, the reason being vertically opposite angles. We also know that both triangle AED and BCE are isosceles. Okay, so both triangle BCE and triangle ADE are isosceles where we know A1 equals D1, so it's A1 equals D1 and DBC DBC is equal to this angle here, BCA, so now we know a triangle has 180 degrees. So if E1 and E2 is actually the same, then we have to subtract that from 180, that size, and the remaining size we will have to divide by 2 in this triangle. Similarly here, we will have to subtract this size from 180 since the triangle is 180 degrees and take that answer and divide by 2. But in both cases we will get the same answer. So therefore this x must be equal to A1. So we can say therefore A1, angle A1 equals to x due to the angle sum of a triangle property together with the isosceles triangle properties. Okay, so it should actually be angle sum of triangle. So from number E, we have proven that A1 is equal to x. Okay, so we know that this angle is x. For number F, we now need to prove that AD is parallel to BC. So these two lines we need to prove as parallel. And now already I can see the Z shape here. So I can say this x is equal to this x here because it is alternating angles. They are on opposite sides of this line, and they are both inside the parallel lines. So we can therefore say that A1 equals x, which is equal to angle BCA, so that we know from E. We have showed it in the previous step. So we can therefore safely say that AD is therefore parallel to BC. Reason being we have vertical opposite angles that are equal. Now that we have proven that side AD is congruent to side BC, we can, or not congruent, rather parallel, we can indicate the parallel properties. And now finally we need to classify quadrilateral A, B, C, D. Well, we know that we have two sides that are equal, and we have a pair of parallel sides. So we know quadrilateral with the property that only one pair of sides are parallel is a trapezium. Furthermore, this is a special trapezium in the sense that the other pair of sides are in fact equal. So it is an isosceles trapezium. So we can safely say therefore that ABCD, so quadrilateral A, B, C, D is isosceles or an isosceles trapezium. So in terms of reasoning, we know that we have AD parallel to BC and AB equals DC. So we have one pair of parallel sides, and we also have another pair of equal sides.